Okay, well, I am very happy to be here physically to see all of your beautiful faces. And my title is just silly long, so I'm going to go straight into it. How many of you are from California? Any more? Everybody I ask is from California. I'm not from California. And when I was growing up, I was fascinated with California because I was on the East Coast and it seemed really different from where I was from. So one of the first classes I took in undergrad was a class in California geography. And I recently found the beautiful map that I made in that class. And what fascinated me was not just that it was different from where I was from, but there were these differences within the state, like the highest and lowest points in the United States only 80 miles away from each other. And then you have areas where you've got these gorgeous coastal rocky coastlines only miles away from redwood forests. And so I then moved to California to get my PhD in geography in 1999, and one of the first books I saw lying around the department was called California, Land of Contrast. And so that started to make sense. That kind of summarized it up for me. And I just defined contrast as a state of being strikingly different from something else in juxtaposition or close association. Okay, so California is a land of contrast, and then there's contrasts even within the contrasts. You have contrasts within ecological systems, you've got mesic and arid environments, you've got coastal and inland. And from a human perspective, you have some of the highest population density in the states, along with some of the lowest population density, and a wide range of socioeconomic characteristics and diverse cultures and peoples. And of course, we have contrasting fire regimes. And thank you, Nicole, for your beautiful presentation. It really helped to set up my discussion. So there are many different fire regimes in California. The map on the right is one where John and I created 8 distinctive fire regime ecoregions. But as Nicole was talking about, we kind of have these broad contrasts. We have dry mixed conifer forests, but other different types of ecosystems that historically burned much more frequently than chaparral. And as Nicole was saying, the natural fire regime of chaparral is periodic, infrequent wildfire that burns at high intensity in ground fires. And so in addition to having these contrasting natural fire regimes, we have contrasts in the way they've been altered, and they've been altered for different reasons. So F4 ecosystems, this is Hugh's map, by the way, his fire return interval departure map, showing you current mean fire return intervals relative to those estimated for pre-Euro-American settlement. And many of the formerly frequent fire forests and ecosystems have been experiencing a deficit in fire frequency, but as Nicole pointed out, in many of the coastal shrublands, there are many more fires than they were historically. And for chaparral species, this can be very detrimental, particularly for obligate seeding species that need a lot of time in between fires to recover. And much of this is due to population growth and urban expansion and the incredible increase in human-caused ignitions that are related. And no matter how you look at it, when there is an altered fire regime in an ecosystem, it can lead to really profound ecological impacts. You can have serious ecological transformations of vegetation type conversion. So altered fire regimes in forests are, in many cases, leading to large patches of uncharacteristically high severity fire, which can lead to type conversion to shrublands or grasslands. But in the chaparral, as Nicole was saying, the type conversion is to these weedy, flashy annual grasses, and that's been happening at a relatively rapid rate in recent years, and is well established that it's been happening in Southern California chaparral. But the human impacts from wildfire tend to transcend all of this ecological variation, particularly in recent years. This is just a 2-year period of time where we had fire events resulting in thousands of structures and lives lost, not thousands of lives, but thousands of structures, in areas all the way across the state, from the wine country to northern interior California, down to Southern California in the Woolsey fire. And we're really looking for a solution to what do we do about this fire risk problem for people living in wildfire-prone places. And a little bit about vegetation management. This is the goal of the topic that this session is about. And vegetation management, it's the primary management tool that's used for fire, and there are two potential objectives. One, to help to reduce risk to communities, and two, to increase natural resources conservation or biodiversity. Now, in formerly frequent fire forests and other ecosystems, maybe sage scrub, I need to figure these out, and you'll see why later, there can be mutual benefits. So in these areas, prescribed fires or mechanical thinning can potentially increase ecological resilience, lead to ecological restoration. It can modify fire behavior, making it safer for communities that are nearby. And it even has co-benefits of cultural preservation by bringing back indigenous burning. But in the chaparral shrublands, there's really no ecological benefit of either mechanical thinning or prescribed fire. They really don't increase biodiversity in the chaparral. And in many cases, the impacts are strongly negative ecologically. It's usually a purposeful or unintentional type conversion to annual grasses. But sometimes it may be needed. It might be a resource sacrifice because, for example, you might need a strategic fuel break around a community to provide safe defense for firefighter operations. And so this creates a conflict in chaparral ecosystems. Oh, I said stay tuned for John tomorrow. He's going to be talking about specific intervals in between fire and different chaparral species, so it's going to be interesting. So where human and environmental systems come together in space and where there are a lot of conflicts and contrasts is, of course, known as the wildland-urban interface, where houses meet or intermingle with wildland vegetation. Typically, it's defined by two types, as Frank was showing, and usually the definition goes according to the Federal Register, and most people are aware of the maps produced by Volker and the Silvis Lab, where the interface is where houses abut with wildland vegetation, and the intermix is where houses that are lower density and are mixed with vegetation. And the WUI is most often thought of in terms of fire. And there's good reason for this, because many studies show that fire frequency does tend to be higher in WUI areas, and houses do tend to be more likely to be destroyed in wildland-urban interface areas. However, there's been other research and other studies and thought about how the development of wildland-urban interface, or just housing development in general, into wildland areas introduces a whole range of other human ecological conflicts. It also involves socioeconomic drivers of the growth and also differences in socioeconomic impacts depending on where you are. Furthermore, the wildland-urban interface, when it's defined just as vegetation and housing, it crosses a wide range of ecosystems, and it crosses a wide range of fire regimes. And fire risk can vary along different places at the wildland-urban interface. And so people have been talking about that, and what I am doing, this is a new project for me, is I'm creating what I'm calling WUI Typologies. And I'm going to read you the definition because it took me a while to actually figure out what it was that I'm doing. It is a landscape classification that delineates distinctive recurring geographical units that distinguish contrast in human environmental systems along multiple dimensions. And the reason for creating these is to facilitate, and Hugh was talking about this earlier, context-dependent analysis, monitoring, and management decisions. And I'm doing this as part of a larger project with UC Santa Cruz. We got a UCOP Climate Action Grant for a project that we're calling WUI Research for Resilience. It's super cool. I'm proud to be part of it. It has multiple different parts. One is an ethnography part where the central question is, why are people moving to the WUI in the first place? Is it amenities? Are they moving there because they want to be with nature? Or is it displacement? Is it affordability? Is it social vulnerability that they can't afford to live in the city anymore? And so it's addressing that. We're doing some prescribed burns. And then I'm also doing this, trying to bring it all together into this framework. And the study focus is the 21 county mega, they call it the Northern California mega region, but it looks a lot more central to me. So that's the big area, but we're also going to do something separately within this 4-county region where we have finer scale data and we can address different types of questions. For example, using habitat corridors that are designed specifically for that area. And what I'm going to address in this, to begin with, are these basic key issues. So if you think about social vulnerability starting at the very beginning, that can drive development into the WUI. And when that development happens, it can lead to habitat loss and fragmentation, and that is especially harmful if it intersects with critical wildlife corridors or places of important wildlife habitat. It can also lead to invasive species. But, of course, moving to the WUI then increases fire risk to people. And depending on what you do, and depending on how you manage it, you then have fault-altered fire regimes in different vegetation types. And so I'm starting out by creating maps that represent different components of these issues. So one example that I did so far is, instead of the WUI map, I created a map showing 3 levels of house risk to wildfire, using 55 fires and the point locations of where homes were destroyed in fires, where they were in a fire perimeter but not burned by fire, or where they were never exposed to fire in that time period. And I created a supervised random forest classification using a suite of explanatory variables that we've used previously, and we created a map with 3 different classes by training it. And this is what it looks like for the region. And I put it up next to the standard Silvis WUI map. And you can see that in blue are areas where structures have been destroyed by fires, and the house risk map that we created does capture some more of those areas than the WUI map. I know there's other maps, I could talk to you about mapping for a long time, but I'm not going to. So here's a hypothetical typology. And it's still a work in progress. And the stuff that Frank was talking about is really interesting because this is in the Central Coast, and I'm really interested in the conditions that are truly appropriate where prescribed fire can be truly beneficial. But hypothetically speaking, this would be an area where you would want to prioritize prescribed fire. So it would be one of the frequent fire ecosystems that had a map showing it had a deficit of fire frequency from fire history. It might also be located in an area that has high housing risk. And furthermore, it might have areas where there's high social vulnerability. So hypothetically speaking, these typologies might be where, yeah, I think we need to go here first and do some fire. On the other hand, you could delineate areas where you should avoid any kind of prescribed fire treatment. So this, for example, I said, I want it to be chaparral. I want it to be young chaparral in particular, less than 25 years old, and have a low to moderate house risk. So in other words, if you do anything to the chaparral here, you can't say that you're going to be benefiting houses because it has a very low fire risk to begin with. So leave it alone. And finally, this is what we're starting. We're developing a few prototypes, but we want to bring this into an online fuzzy logic decision support system that we call EAMS. It's hosted by the Conservation Biology Institute. And what's cool about it is that you can bring the maps into this online platform and make it dynamic and flexible. So you can change thresholds to visualize how that changes throughout the map. So this one, what is it? It's a terrestrial intactness thing. So for example, one of the criteria that goes into the model is high percent natural core area. So what if you change the number that makes percent? What if you say high percent equals 60 versus 50? What does the map look like when you do that? And so when I say something like young chaparral, John will be telling you tomorrow, for some species, they can deal with 15 years between fires. Other species, they might need 25 years in between fires. So this platform could allow you to dynamically move that threshold to see how it changes the areas. And I'm hoping it can be used for monitoring as well to see how these areas are changing. Okay, last slide. Oh, no, I lied. So what we want to do is match typologies to solutions. So here's some of the examples of issues that we're worried about. Here's a list on the right of all the different types of solutions and strategies we could use. And the key is to match the right strategies with the right issues without matching the wrong one. So for example, we were talking about prescribed fire. Well, you might want to do that to deal with fire risk in the WUI. You might also want to do that for certain ecosystems, but you wouldn't want to do that for short interval fire. So you can imagine a whole bunch of arrows going back and forth to help match up these solutions with the appropriate typologies. And consider trade-offs and unintentional consequences. So in summary, the objectives of this new project are to delineate contrasting landscape types, to actually create a spatial framework to look at contrast in both ecological and social systems, and to consider a wide range of issues. And the issues that I'm dealing with in the Central Coast are those that are parts of the project, but we hope the project continues in the future and we'll learn and we can adapt it as we go. And it's really important, as Hugh and Nicole were saying, especially with Chaparral, to match the strategy with the ecosystem type, because one size does not fit all. You can have unintentional consequences. You could actually increase your fire risk when you think you're decreasing it because you've just brought in all kinds of grass that's really flammable. So we're hoping it can be flexible and adaptive. By putting it online, maybe stakeholders can go in and look at things, decision makers can go in and look at things. And the other thing is that while we're doing it at 2 spatial scales now, there is no such thing as a static WUI typology. All of these different variables are going to be changing. So in the future, maybe we can make it dynamic. That's it.